Okay, good day. This lecture we will be studying chapter 14, and this is about work and energy. Okay, so now this concept is just another way of solving problems involving force, velocity, and displacement. So uh, we can see later on problems that we had in chapter 13 can also be answered using this method, work and energy. Okay, so first, let's define the work of a force. So, based on figure 14-1, we have a force that is acting on the particle, and the particle undergoes a displacement from position R to position R prime. Okay, so the displacement is just R prime minus R. The magnitude of this vector dr, which is this displacement, is just ds, or the arc length from R to R prime. Okay, so if we are now going to get the work that is done by the force F to the particle, so this is just equal to du, which is the symbol for work, or u rather, is just equal to F multiplied by ds cosine theta, or in other words, we only multiply the component of the displacement that is in line, that is along F. Okay, or in other words, we can only get work when our force and our displacement is aligned. Okay, so ang pasabot ani, since this is F, this is ds, this one, so we only get the component of ds that is aligned with F. Okay, so we can actually get or write this one in vectorial notation as du is just equal to f dot dr. So meaning of that product is it will only give you a value when the force and the displacement is in the same direction. Okay, now what happens when f and the displacement is at opposite direction? So makuha ni mong work ana is negative. Okay, so kung sample diri ang imo ang displacement padong, then ang imo force is opposite, like the work of friction, no? Always opposite man na sa mga displacement, so it will be negative. Okay, how about if the force and the displacement is at perpendicular to each other? So ang work na imong makuha na is 0, no, kung perpendicular, kay ang cosine of 90 is 0. Okay, now ang unit ani, what is the unit of work? The unit of work is measured by joule, or this is just equal to 1 Newton meter. Okay, let's proceed with determining the work that is done by a variable force. Okay, so what if the force that is acting in the particle varies as it goes from point 1 to point 2? So ang imong buhaton na is that you sample kani. Okay, so kani nga line nagrepresent sa variable force. So ang buhaton na is you sum up the work using this integral f cosine theta ds integrated from S1 to S2. Now take note kaning f cosine theta mo man ni ang equation ani nga line. Okay? By the way, so you are all familiar how to get the area. No? Area under ani nga curve using integration. Okay? You just get a small strip and then multiply the height by the width, which is ds. Integrate from S1 to S2. That's how you get the area under this curve, or in this instance, the work. Okay, how about if the force is constant? So just like this one, when the particle is moving from point 1 to point 2, always acted by a constant force. So dali na siya. You just kung constant ni siya, you just transpose it outside and then integrate this one. Or in other words, this is just equal to fc cosine theta s2 minus s1. This is just the area of this rectangle. Okay, example. So, work of a weight. So, ang work of a weight is, ang weight nimo is considered constant, no? So, how do you get the work of the weight, no? If the particle moves from S1 to S2, paangat siya, angat. Then, ang imo ang weight is paubos. So, apply this equation. By the way, if you want to use the Vectorial form, so kani siya. Ang imong work is just negative Wj dot, what is dr? Ang dr nimo is dxi plus dyj plus dzk. Okay? So, the only component nga maghatag sa imo og value ani is kaning negative wj dot dyj. Kay ang jni is 90 degrees man na sila, and jnk is also 90 degrees. So, 0 ang labas ana. So, ang only component is negative w dy. Is just equal to wherein ang imong dy is just y2, kani y2 minus y1. Okay? Therefore, ang imong work is just negative w delta y. Now, if the particle is moving downward, say for example, kung gikan sa direct S2 and then munawag sa S1, the work will be positive. Why? Because the displacement will be acting downward, and also ang imuang force is also acting downward. Okay, so muna sa timan if the force and the displacement is in the same direction, the work will be positive. But if the work and the displacement is at opposite direction, you will get a negative work. Okay, let's proceed with work of a spring force. What is the work that will be done if you have a spring and you attach a particle at the tip of the spring? I say, for example, this figure 14-5. Okay? So imagine that you have a particle that is attached at the end of this spring, and then you stretch it. No? When you stretch, so the displacement would be going in this direction, to the right, going to the right. Okay? Going to the right. But ang imong force, no, if you get the free body diagram of the particle, no, will be going to the left. So therefore, baliktad ang iyang direction with its displacement. So that is why, if you evaluate this one, you will get negative ks ds integrated from s1 to s2 because ang imo ang F is just K times S, or the spring force times the displacement. Okay, so therefore your work from 1 to 2 will be negative 1 half K S sub 2 squared minus 1 half K S sub 1 squared. Okay. Now, so that is for, now if you elongate or you stretch. How about if you compress? So kung i-compress nimo, still you get a negative work. Okay. Okay, so let's have this example in order to illustrate or determine the work that is done by the force P to this block. Okay, so you have a 10 kilogram block shown in figure 14.6a rest on a smooth incline. So this is a smooth incline. If the spring is originally stretched 0.5 meter, determine the total work done by all the forces acting on the block when a horizontal force P equal to 400 Newton pushes the block up the plane 2 meters. Okay? Okay, so this is the problem, and we have a 10 kilogram block is resting on a smooth incline. So if the spring is originally stretched 0.5, so actually this is the original length of the spring, and then i-stretch na sa daan ng 0.5, so nanakaroon ang imo ang block dire. Okay, determine the total work done by all the forces acting on the block when a horizontal force P, which is 400 Newton, pushes the block up the plane 2 meters. So the scenario is this the spring is already stretched 0.5, and from this position the push up to 2 meters. So we are to determine the total work done by all the forces. So it is necessary to first make a free body diagram to show all the forces that are acting on the block. Okay? So if we draw the free body diagram, now if you have a wrong free body diagram, then it is expected na wrong po din mo answer. Okay, so this is the block. First, you have weight, mg. And then you have P, force P. Since gingon diri nga it is a smooth incline, meaning there is no frictional forces. So, wala frictional force. So, also pa yung forces that are involved. You have the spring force. Okay? Spring force acting opposite sa imong motion. And lastly, you have the normal force. Okay? This is the normal force. NB. Okay, so if we get all the work done by all these four forces, sum it up, so we can get the total work. Okay, so for NB, or the normal component, so ang work is just 0. Why? Perpendicular na sa imong motion, no? Ang imong normal is perpendicular sa imong motion. Another one, work done by P. Work done by P. So, sa buhatan na ni. Ano? U din ni. U sub N. Okay? U sub P is just you get the component ani nga force ano ni horizontal ni get the component ani nga force that is parallel, no? Parallel sa imo ang motion, so kani. So this is just P cosine 30. Okay, 30 man na. 30 degrees. So becomes P, which is 400 cosine 30 multiplied by displacement. So pila ang displacement ani? So ang displacement ani is man gikan na mong P apply so dire, no? Pwede mo sa to. So this is 2 meters. Okay, so ang answer ani would be 692.8 joule. 692. Okay? Work done by spring force. What is the work done by spring force? Again, this is just negative of, this is the equation, negative 1/2 of KS2. Okay. So the equation is just negative. Laro na ipagawas ng K. Negative 1/2 K S sub 2 squared minus S sub 1 squared. So this is just negative 1/2 times ang K, 30. Ang imo ang S sub 2, diri man nagikan ng S nimo. S sub 2 nimo is kani. S sub 1 nimo is kani 0.5. So S sub 2 nimo is, your S sub 2 is 2.5. Diba? 2.5 gikan sa imong original length padung sa final. 2.5 squared minus S sub 1 is kani padung diri. Initial niya nga. So kung wala niya na stretch daan, so 0 na siya. No? But since na may 0.5, so 0.5 squared. So ang answer ani would be negative 90 joule. Again, ganun negative since opposite man yung direction. And then, lastly, you have the work done by the weight. Ang work done by weight is just, so again, work done by weight, paano mo ang component ani? Parallel sa imong motion. So kani nga component. That is just mg again, this is 30 sine 30 mg sine 30 times 2 meters. Tama? mg sine 30 times 2 meters. So again, opposite man isa sa imo ang motion kani ang direction pa ana. So negative ni. So you have negative 9.81 times 10 sine 30 times 2. Ang answer ani would be negative 98.1 joule. Okay? Therefore, the total work, sum nimo ang tanang work, sum nimo ni kani. So the answer would be 505 joule. Answer would be 505. Okay? So medyo same naman na siya, di man siya kayo. So thank you.